And but talking about the way forward, you worked a lot on calibration. Do you think the calibration is part of the way forward, or that every model should come with some kind of a calibration metrics, and we should understand and extend these calibration metrics to some other tasks, even beyond predictive models as well? So, can you tell us what should a calibration model be?
Yeah, well, I think I read a book a while ago, a Dutch book. I think it was a novel, but it was about, in the old days, okay, let's say you go to a grocery shop and there was a weighing device there, okay? And it's important because you want a kilo of rice, then they weigh the rice and then you pay an amount of money. Now you would want that weighing those scales to be calibrated, and actually it's clear that there's a bit of a conflict of interest if the grocer calibrates their own weighing scales, because then they would probably make sure that they indicate a bit higher weight. So there were people going around and certifying those instruments. And they would put a sticker on it or a stamp on it and say every once a year that device needed to be calibrated, because that's important. That's what we base our decision on. We're forgetting a bit about that, because most measuring instruments are now digital, and they give the impression of being calibrated, because you eliminated the what's the word for it? You don't have uncertainty about the number, because the number is there in digital form. It doesn't mean that there isn't a measurement error, right? So this idea of anything that measures needs to be calibrated to a meaningful scale. If you go and get petrol in a petrol station, how confident can you be that you really got 40 liters, right? Maybe you got 35 liters. So the notion of calibration, whenever you measure, you want to be sure that those measurements are calibrated to some known scale. Or if you take your body temperature, you want a thermometer that is calibrated, because maybe you decide that you have a fever and you call an ambulance because you have a fever. So this is a very common thing, but people forget about it because they kind of think, oh, my oven says 240 degrees, so it must be 240 degrees. So in machine learning, I realized that in machine learning, the typical thing that we do is we manipulate probabilities. And this is like in weather forecasting. So if the weather forecast says 70% chance of rain, that's not a subjective probability. That's really something that's a calibrated probability, in the sense that if we take 100 forecasts where it says 70% chance of rain, then we would expect 70 cases there was rain, and in 30 cases there wasn't rain. And why is this important in machine learning? Because then we can sort of communicate probabilities, and we know what it means. So one algorithm produces a probability, another algorithm consumes the probability, and they both agree on what that probability means. If we don't have that property, then we can't really combine those two algorithms or modules together. So that's kind of a high-level overview of why I think calibration is important. And yes, I think it will remain important, because it allows us kind of a common standard for different algorithms to communicate, also for people to communicate, so that we know what we mean. If you say, well, I'm 60% certain, if that's purely subjective, then all I know is that 60 is more than 50 and less than 70. But if it's calibrated, I know a little bit more.